Hello everyone. We discuss about work, energy and power. Chapter short notes. Work done. Work done. W is equal to dw f dot dr f dr cos theta, where theta is angle between f and dr. For constant force, W is equal to f dot d fd cos theta f dot d fd cos theta. For unidirectional force, W is equal to dw f dx, area between fx curve and x-axis. Nature of work done. Although work done is a scalar quantity, its value may be positive, negative or even zero. Negative work, zero work, positive work. Work done by friction force. Theta is equal to 180 degree. Motions of the particles on the circular path uniform. Theta is equal to 90. Motions under the gravity. Theta is equal to 0. Theta is equal to 0. Work done by gravity. Theta is equal to 180 degree. mg. So 100 Newton as F. Hence S is equal to 0. Work done by friction force on the block A. Theta is equal to 0 degree. Work done by the variable force. A force varying with the positions or the time is known as the variable force. Calculations of work done from force displacement graph. Kinetic energy half mv square half m dot v. The energy possessed by a body by virtue of its motions is called kinetic energy. K is equal to half mv square. Kinetic energy is frame dependent quantity. Work energy theorem. W is equal to del Ke. Change in kinetic energy is equal to work done by all force. For conservation force, change in potential energy del U is equal to minus F x dx. Conservative force. Work done does not depend upon path. Central force, a spring force, etc. are conservative force. Work done in a round trip is 0 when only a conservative force acts within a system. The kinetic energy and potential energy can change into each other. However, their sum, the mechanical energy of the system, does not change. Work done is completely recoverable. If F is conservative force, then F into V into F is equal to 0. Non-conservative force. Work done depend upon the path. Work done in round trip is not 0. Force are velocity dependent and retarding in nature. For example, frictions, viscous force, etc. Work done against a non-conservative force may be dissipated as heat energy. Work done is not recoverable. A body may gain kinetic energy and potential energy simultaneously because principle of the conservation of mechanical energy may not be valid every time. Comets move around the sun in elliptical orbits. The gravitational force on the comet due to sun is not normal to the comet's velocity, but the work done by the gravitational force is 0 0 in the complete round trip because gravitational force is a conservative force. Work done by the static frictions may be positive because static frictions may act along the positive directions of the motions of an object. Potential energy possessed by a body by virtue of its positions or configurations in the conservation force field. Potential energy is a relative quantity. Potential energy is defined only for the conservative force field. Potential energy of a body in a conservative force field is equal to the work done by the conservative force in moving the body from its present positions to the reference positions at a certain reference positions. Potential energy of the body is assumed to be zero, or the body is assumed to have lost the capacity of doing work. Relationship between conservative force field and potential energy. A force varies with only one dimension, say along x-axis. F is equal to minus du upon dx. Del u is equal to minus wc. Potential energy may be positive or negative or even zero. Potential energy may be positive or negative or even zero. Repulsion force, attraction force. Potential energy is positive if force field is repulsive in nature. Potential energy is negative if force field is attractive in nature. If R is increases separations between the body and the force center, U increases force field is attracted or vice versa. If R is increases, U is decreases force field is repulsions in the nature. Potential energy curve and equilibrium. It is the curve which shows the change in potential energy with the positions of particle. Potential energy, positions of particle. A stable equilibrium after a particle is slightly displaced from its equilibrium positions. If it tends to come back toward the equilibrium, then it is said to be in a stable equilibrium. At point A, slope du upon dx is negative, so f is positive. At point C, slope du upon dx is positive, so f is negative. At equilibrium, f is equal to minus du upon dx is equal to 0. At point B, it is the point of a stable equilibrium. At point B, u minimum du upon dx is equal to 0. d square u upon dx square positive. Unstable equilibrium. Unstable equilibrium after a particle is slightly displaced from its equilibrium positions. If it tends to move away from equilibrium position, then it is said to be in unstable equilibrium. At point D, slope du upon dx is positive, so f is negative. At point G, slope du upon dx is negative, so f is positive. Point E, it is the point of unstable equilibrium. At point E, u maximum du upon dx is equal to 0 and d square u upon dx square negative. Neutral equilibrium after a particle is slightly displaced from its equilibrium positions. If no force acts on its, then the equilibrium is said to be neutral equilibrium. Point H corresponds to neutral equilibrium. U is constant. Du upon dx is equal to 0. d square u upon dx square equal to 0. Law of conservation of mechanical energy. Total mechanical kinetic plus potential energy of the system remains constant if only conservative forces are acting on the system of the particles, or the work done by all the others force is zero. From the work energy theorem, del K E, W is equal to del K E. For an internal conservative force, W instantaneous is equal to minus del U. So W is equal to W external plus W instantaneous is equal to 0 plus W instantaneous is equal to minus del U is equal to minus del U del in under bracket kinetic energy plus U plus potential energy external is equal to 0 kinetic energy plus potential U kinetic energy plus U potential energy constant. A spring force F is equal to minus kx elastic potential energy and stored in the spring U into x bracket is equal to 1 upon 2 kx square. Mass and energy are equivalent and are related by the E is equal to mc square. Power. Power is a scalar quantity with the dimensions m1 L square T minus 3. SI unit of the power is joule per second or watt. 1 horsepower 746 watt. Power average power P average is equal to W upon T. P average is equal to W upon T. Instantaneous power P is equal to dW upon dt. Now instantaneous power P is equal to dW upon dt is equal to F dot dr upon dt. F dot B Relations between kinetic energy and linear momentum. P is equal to mv and K is equal to 1 upon 2 mv square 1 upon 2 m in bracket m square b square. P is equal to P square upon 2m. K is equal to P square upon 2m. P is equal to under root 2 mk. P constant, K constant, M constant. Geometrical interpretation of work done area under F versus and curve. Positive work, negative work, positive work, negative work.